Going to discuss an important topic called process versus thread. As I told you before also, what is process? Process is program under execution. Program under execution. So what is program? Program is set of instructions. This is stored in hard disk and this is stored in RAM. Okay, so this is in basic terms what is process. Program under execution or whatever it is running in RAM is called process, and program is set of instructions and it is stored in hard disk. Okay, and what is thread? Thread is light weight process. Why it is needed? Let me tell you why it is needed. So before that, if you want to understand why it is needed, you must understand what is system call. System calls, these are the services provided. These are the services provided by an operating system to access IO devices or to access hardware or to access IO devices efficiently. Okay, now what you are trying to do is, see, there are different types of system calls. One of the system call is, let's say, get PID or set PID, or let's say you want to format your hard disk, so format is a system call. Another system call is, let's say, printf. So printf is a function call, but then inside printf function call we are calling system call like write. In scanf we are reading from our keyboard, and keyboard is a IO device, so we are reading something inside the scanf. We have something called read as a system call. Similarly, we have one more system called fork. Fork is a system call used to create a process, create a child process. Now let's say if there is one process P1, this process has called fork as the system call, then what will happen? It will create P1 and C1. P1 was this one only, and C1 is its child, or you can say that exact copy of P1. Why it is needed to have exact copy? Let us understand that why the exact copy is needed. See that I'll give you an example, very simple example. So let's say I have a web server and I have multiple clients. Let's say client 1, client 2, client 3. Now this client wants to log in this web server. So there is a process running which is handling all the requests. If I will make system call to make P1 who handles C1, and I will call fork to make P2 which will handle C2. If I make another fork and create P3 which will handle C3, there will be few disadvantages, because for everyone I need to call fork, because they will create process, duplicate process. Okay, what is the disadvantage? The disadvantage, one of the very big disadvantage is lot of memory is wasted. Why lot of memory is wasted? If size of P1 was 1 MB, then P2 will also require 1 MB P3 will also require 1 MB. And if I have 1000 clients, then it will require 1000 MB of memory. Now it may seems to you that 1000 MB is not a big deal. Okay, 1000 MB is just like 1 GB and it is not more or not much. But then if we can save 1 MB also, then we have optimized our computer or we have optimized our web server. Apart from lot of memory wastage, it is very slow. Now you do not want to waste your time or you cannot wait to log in or get the response from the server. If you want to log in on Facebook and let's say for login on Facebook you have to wait for 5 minutes, then you will get frustrated. So simply we cannot afford to be slow. So for that, because why it is very slow? Because system calls are slow. System calls are slow. And why they are slow? Because they make context switches. They make context switches. And if you don't know what is context switch, so let's say this is my process CPU line. This is my CPU timeline. Let's say here I am running P1. So P1 is running, but then here let's say timer interrupt occur. Timer interrupt occur. Now P1 wants to go out because timer interrupt occurs and some other process P2 wants to come in. So in between what will happen? Context switch. We will load. Before loading, what we will do is we will store the context of P1. Why? Because when it will come back after some time, if P1 will come back after some time, we do not want to start it from the first. We want to start it from the last point it has left. Let's say 100 lines of code are there in P1. 10 lines of code are already executed. So do we want to start from 0th line again? No, we want to start from the 11th line because 10 lines are already completed. So where we have to store that information, how many lines are completed in our context. So we will store the context of P1 and load the context of P2. That is पुराने वाले प्रोसेस का कॉन्टेक्स्ट स्टोर करना है और नए वाले प्रोसेस का कॉन्टेक्स्ट लोड करना है. दिस इज कॉल्ड कॉन्टेक्स्ट स्विच. And context switch is time consuming because we have to store something and we have to load something. And in system calls it is needed 2 context switches. एक नहीं 2 context switches होते हैं. So system calls are slow. So that's why it is very slow, time consuming. Okay, so if we do not want to do this, what is the better method to make our web servers faster? So using threads. Using threads is a faster method to make web servers. I am just giving you an example of web server, but otherwise threads are used in very vast area. Okay, so let's say web server. This, and we have one process, and this one process is having T1, T2, T3 threads. So each client T1 is handled by each thread. Now these threads are sharing some memory. They will sharing some memory and have some exclusive data. For example, if it is about login, then this T1 will handle the username and password of C1. This T2 will handle the username and password of C2. This T3 will handle the username and password of C3. Whereas to authenticate, to match the username and password from our database, it will remain the same code. T1 will have the same code, T2 will have the same code, T3 will have the same code. So it will share some data and have some exclusive data. So that's how we can save the memory. Memory is not wasted now. And it is not slow because in form of creating threads, we are not using context switch if we are talking about user level thread. So I am coming up to the types of thread in a moment, but then if it is about user level thread, then we do not have to make any context switch, we do not have to make any system call. So if we are not making system call, then we do not have to make any uh, context switch, and it is not slow, so it is very fast. So now what is this some sharing and some exclusive? Let's understand this in a better manner. Okay, so now see this. Each and every process, let's say I'm talking about process first. What is process and what a context is made up of? A context is having stack, it is having heap, it is having data, then code, then file descriptor, and it is also having registers, it is also having program counter. Now if I am making p1 and I am calling fork system call, then again the same data, this stack, this heap, this data, this code, this file descriptor, and here registers, here program counters, everything will be there, everything will be copied again. So that's why it is wastage of memory. But if we talk about threads, then threads are like this. Under one process P1 only, we have multiple threads. So for example, I am taking example of 3 threads. So this is, let's say, T1 thread, this is T2 thread, and this is T3 thread. So they are having their own stack, stack is exclusive, their own registers are exclusive, their own program counters are exclusive, and they will share data or heap, they will share code, they will share files. So you can say that this is shared memory between all threads. And see here, data and code, data, heap or code or files, these are the larger size, larger amount of data is available here only. Program counter is how much? 4 bytes. Register is how much? If we are having, let's say, 4 registers also, then also 16 bytes. If we are talking about stack, then stack will also have not more than 2, 4 or 10 variables, which is again 40 bytes. But code can be of 1 KB, 2 KB. Files can be of 1 GB also. Data can be of I don't know, maybe 1000 MB or maybe 1 MB or maybe 1 GB or 1 terabyte also. So these are the huge data. So we have made the huge data shareable so that we do not have to copy again and again, and rest all other things are exclusive. So this is how the threads are working. Now we have 2 types of thread. One is user level thread and another one is kernel level thread. Okay, so I am telling you what is what. Before that, understand this. In case of user level thread, if you want to create a thread, you are not informing to the external party. Okay, you are not informing to the external party. Let me give you a real life example. Let's say inside your house, if you want to do some function, then probably you will not involve any police permission, that I want to do some jalsa kind of thing in my own house. So let's say police is a third party. But let's say if you want to do some community program, what is community program? For example, you want to do some community jagran or something. So in that community program, you have to inform police for the permission. In our computer science, what is that police? Is our operating system. This is our police in our computer science. Now, if you are creating a thread in user level thread, you do not have to inform operating system. You do not have to inform operating system, and you can make any number of threads. So it is fast. This is user level thread. But in kernel level thread, if you are creating thread, first of all you have to inform operating system and then you can create thread. Then you have to first inform the operating system, then you can create thread. So this is little slower than the user level thread, but there are its own advantages. Let me come to the advantage and disadvantage of each of them, user level and kernel level. So if I talk about user level thread, user create the new thread, operating system is not involved. Okay, another one is switching between threads, also operating system is not involved. Okay, so this is user level thread. What is the advantage? Advantage is simple. It is fast. It is not complex, or rather we can say it is simple. Okay. Or again, the advantage of threads, using thread, is we are not wasting memory. What are the disadvantage? First disadvantage is, even if one thread is blocked, all threads under that process are blocked. What I mean is, let's say this process is blocked because of some reason. So this operating system will think something is wrong here and it will block the whole process, because operating system don't know how many threads are available inside that process. You have not told the operating system while creating the thread. जब आपने थ्रेड बनाते हुए ऑपरेटिंग सिस्टम को बताया ही नहीं कि थ्रेड बना रहे हैं, तो जब आपका एक थ्रेड ब्लॉक हो जाएगा तो ऑपरेटिंग सिस्टम को लगेगा कि पूरा का पूरा प्रोसेस बंद हो गया है, उसको तो थ्रेड के बारे में पता ही नहीं है. सो दैट्स व्हाई व्हाट विल हैपन, if one thread is blocked, all the threads under that process are blocked. So that means whole process is blocked. Another disadvantage is unfair scheduling. Unfair scheduling. What is the meaning of unfair scheduling? So let's say this is P1 and here we have 3 threads. This is P2. Let's say here we have 5 threads, and this is P1, let's say P3, and it is having only 1 thread. Now if we assume that we have round robin scheduling algorithm, then time quanta is, let's say, 2 millisecond. So operating system will give 2 millisecond to this, 2 millisecond to this, 2 millisecond to this, and this is unfair actually. Why this is unfair? Because these 2 milliseconds are for 3 threads, these 2 milliseconds are for 5 threads, and these 2 milliseconds are for 1 thread. So for 1 thread also we are giving 2 millisecond, and for 5 threads also we are giving 2 millisecond. But this is unfair scheduling, because operating system is allocating this time, and operating system don't know, operating system have no idea how many threads are available inside the process. So it is unbiased from its own side but then ultimately it is getting biased. Okay, so these are the disadvantages, and now these disadvantages are overcome by kernel level thread. So the second one is kernel level thread. In kernel level thread, these disadvantages are overcome. How are these overcome? Now we will involve operating system in the process of creating the thread. So let's see about kernel level thread. So in kernel level thread, now to create a new thread, we have to make a system call. Why system call? Because we want to inform the operating system. Okay, we want to inform the operating system to make kernel or operating system aware of different threads. So while creating thread, let's say we are creating this thread. So after creating this thread, if we want to create another thread, first of all we have to make system call, and after that we can create thread, another system call, then we can create another thread. So these threads after creating system call. So now if this gets blocked, then operating system knows that there are more than one thread, so it will get blocked only, other threads will work as it is. So now if this gets blocked, or we can say that now if one thread gets blocked, then other threads will work as it is, they will not get blocked. So this was the disadvantage in user level thread. Now you may ask me, sir, here we have made system call, so obviously we have made it slower. So I have told you user level thread are faster than kernel level thread because of this very reason. But then there is another advantage which is not available in process. In process there were two disadvantages. One was slow, which is available in kernel level thread also, because we are making system calls. Another disadvantage was wastage of memory in process, whereas in kernel level thread at least we are not wasting memory, because here some things are exclusive and other things are common. These are shared things which I have told you above, which is data, heap, code, files, etc. And now since operating system know how many threads are available inside each process, so appropriate scheduling will be done. So now there is no unfair scheduling, because let's say this P1 is having 3 threads, P2 is having 5 threads, P3 is having 1 thread, and we are running round robin with time quanta of 2 millisecond. So this will get 6 millisecond, this will get 10 millisecond, this will get 2 millisecond. Now it is not biased, because operating system know how much threads or how many number of threads are available inside a process. Okay, now this is all about the threads, user level thread and kernel level thread. But here we have other disadvantages which I already told you. What is the disadvantage? Expensive as compared to user level thread for creation, because we are using system calls here, so that's why it is expensive. And another one, switching a thread required system call. In user level thread, if we want to switch from T1 to T2, then we can switch directly. but here if we want to switch from T1 to T2, we have to make system call again, so it is again time consuming. So this is user level thread and kernel level thread. And lastly, I'll tell you a hybrid thread. So hybrid thread is combination of user level and kernel level thread. So I'll just give you a diagram, and by that only you can understand. So what is hybrid thread? So let's say this is our process P1, this is process P2, and let's say this is process P3. Inside this process we have these threads. Inside this process, let's say these threads are available. So let's say this way they are connected like this. Okay. Okay, what is what? Let me tell you. So these all are user level thread. This is user level thread, user level thread. These are kernel level thread. These are kernel level thread. This all are kernel level thread. Okay. And this is what? This is what? This is, you can say that, combining unit. Combining unit. Okay. Now see this. This is a combination of kernel level thread and user level thread. Now, if this thread gets down, what I mean by get down? Let's say this thread is blocked, then this whole thing will get blocked. Okay. If this thing got blocked, then only this thing is getting blocked, not this thing will get blocked, because this is a kernel level thread. Maybe you can understand like this. Let's say if this thing is blocked, then this will get blocked, this will get blocked, all these things will get blocked. But let's say if this thing is blocked, then this will run, this will run. So this is a hybrid kind of thread. Okay, so in general, if somebody asks you what is hybrid thread, so it is a combination of user level thread and kernel level thread, so that we can use the advantages of user level thread and advantages of kernel level thread, and we design it in such a manner that we avoid the disadvantages of both. Okay, so this is how you can define it. Okay, so this is whole about threads.